Are we good, Brittany?
I don't see it yet.
Okay, let me update my YouTube link over here.
Yeah, you're good.
All right, awesome. All right, hello everyone. It's a little after 11:01, so we're going to get started. We have a wonderful presenter for you today, Dr. Kimberly Miner. She is a research assistant and a professor, so she loves, teaching. And one of the things that she wanted to share with you guys today is all of the ways that you can be involved in the field of science. And we're very excited to have you again, Dr. Miner. Thank you very much. Please take it away.
Thanks, Debbie. Yeah, I'm really excited to be here. I gave a little talk that was similar during the teach-in, the National Biodiversity teach-in during the actual day. And it was really fun to get tons of questions from everybody. So I'm really hoping that we can do that again and that we can get a lot of questions and have an interesting and fun conversation over text. So I'm going to be talking today about field science and climate change. I am a climate change scientist. I'm a research assistant professor at the University of Maine. And I work all across the world, especially in high alpine regions, looking at the ways that the world is changing because of climate change and because of different warming patterns. So this is in Alaska. This is actually taken from a helicopter. I had the privilege of choppering off of a glacier in Alaska, kind of outside of Fairbanks. And it was very, very beautiful. And we were able to see it from this giant window in the helicopter. So it's an awesome experience. And I'll have some more pictures to share with you from that. Let's see, I'm trying to make the presentation move forward. There we go. So this is a picture of me. Unfortunately, I don't have a camera on my computer, so I'm not able to talk directly to you through a camera, but this is what I look like. This is my dog, and this is a picture from the campus of the University of Maine. And it's a really beautiful campus, and my dog and I used to run around without a leash even when the students were gone in the summer. And I'm sure all the students are gone right now. So if we were still in Maine, we live in DC now, but if we were still in Maine, I'm sure we'd be able to run around without a leash. So it looks like the picture on the left is a little blurry. I do apologize for that. These are some of the pictures from Antarctica. So on the left is an image from the British base Rothera. And they brought us out to one of the glaciers near the base, and we went skiing for the day. And that's how we got out, was in that really, really amazing giant snow crawler, very bumpy. The seats are not very padded. So a lot of the things in Antarctica aren't comfy, but they're very beautiful. And this is on the right, some of the crew that I went with. This is the team from Columbia University that I was a part of. Obviously, I'm the one in the blue jacket with the blonde hair. And as you can see behind us are a bunch of different glaciers and also icebergs floating on the water. So we took a ship from the southern tip of Chile through the Drake Passage, which is a really, really turbulent water body. It's part of the ocean, it's part of the Southern Ocean, but it's distinguished in that there's no land masses anywhere in the Drake Passage. So the circulation of the ocean can get really, really fast, which means that you get a lot of waves. So we took a boat all the way through the Southern Ocean, down to Antarctica and to Palmer Station, which is one of the US research stations. And it's a really neat place. It's not huge, but there are some very beautiful vistas and some pretty good facilities for science. So one of the other places that I talked about last time was Banff National Park in Canada. And during my PhD, I had the opportunity to hike up to these glaciers and take water samples and snow samples. I think I have a picture of that. Yeah, all right. So here's some more pictures than I was able to find between this time and last time. So just taking water samples, that's a glacial meltwater stream. And I don't think I've got any more of those photos, unfortunately, but it's really, really blue, beautiful water, as you can see on this earlier picture. The water is really, really clear, but because of the way that the glacier turns rocks into soil when it moves, it kind of grinds down the bigger rocks and turns them into smaller particles. You've got a really interesting texture and color to the water and these tiny, tiny particles of soil. And then again, that's another picture on the right of the same kind of lake system. You can see there's valleys, there's these peaks and valleys you can see along the vista there. The valleys are created by long time ago by old glaciers moving along the landscape and really transforming the landscape so that the parts where the ice wasn't on for as long make the peaks, and the parts where the ice was grinding down and melting over time make those valleys, and they make the glacial moraines. All right, so you've already seen this picture on the right for Alaska. This is a neat little show and tell opportunity for me, so I appreciate everyone giving me the chance to chat about this. So on the right was taken from the helicopter. On the left, you'll see an ice core. That was not the same ice core that I'm looking at below, but it was taken in the same region by, I think, my advisor and his team, Carl Kreutz at the University of Maine. And then below, I am at the Army Corps facility in Alaska in a very, very cold room. I actually took my hair down just for the photo because normally we have full gloves, hair up and covered with a nice warm cap and sometimes even scarves because those coolers are kept around -20 degrees Fahrenheit, which is really, really cold. And so you can't spend very much time in there. I had this really interesting methodology where I actually had to use a table saw to cut a tiny part of the ice core off for all of my work. So we took pictures of the ice core and got a good idea of what it looked like when it was pristine. And then I cut a section off, and then the other researchers took sections, cross sections, or chunks for their research. I looked at chemicals, pesticides like DDT in the ice core, but some of the other people looked at chemistry. They looked at the way that the glacier moved, the crystalline structure, the flow, all sorts of different things like that. This is another picture from Alaska. This is our tents. This is the day that we started the expedition. So on the left is my tent, and it is obviously the lowest. That's because I thought I was being very clever. And I dug a really, really, really deep hole for my tent, and I built a really strong wall around it so that the wind would just go straight over my tent and I would have a beautiful resting place with very little wind, and it would be great. Well, what I did not expect is that we had an 8-day blizzard starting that evening. So my tent was the first to get covered by snow. And it was also one of the most impacted tents. I ended up having to move into somebody else's tent. And so that was something that we really struggled with. It was a challenging 8 days, spent a lot of time eating Snickers bars and playing games and reading the same books over and over again. But our expedition leader was awesome, and he was able to get all of us through safely, which was great. That's a picture on the right of the lab afterwards. Once I've got all the pieces from the ice core, I was able to melt some down, put it through what's called a semi-permeable membrane extractor. And we were able to filter out all the different particles that we are looking for. So I've started to get some questions. I'm going to go ahead and start answering them. The first one is, have you found any plastic pollution in your research? So I just finished some research with the National Geographic Foundation and Rolex, and we found PFAS, which are parts of plastic. They're like the waterproofing stuff that goes on tents on Mount Everest. And one of my colleagues did find plastic pollution on Mount Everest, and we both found a lot more than we were expecting. So all of that research is going to be coming out in July with an article, or I'm sorry, with a journal that we're publishing. Well, probably July or August. And then we'll have a lot more to talk about with that. So stay tuned. Let's see. I know soils carry metal contaminants in streams. Would the atmosphere carry metal contaminants to those streams? Okay, great question. So it kind of depends on what kind of metal we're talking about. So if you talk about things like lead, we are able to see where people are either making or using lead, and it travels through the atmosphere and is deposited on glaciers. Now, a lot of metals are heavy, so it makes it a little bit challenging for some of them to be carried atmospherically. But there's also metals in the rocks, okay? So you hear about things like arsenic being released out of Himalayan glaciers and Himalayan streams, and that's because that's already in the rocks. So you got a little bit of both, different kinds of compounds carried through the atmosphere and different kinds of compounds in the soil and in the rock. All right, I've got one more question, but I'm going to go ahead and move on to the next slide, so you guys have something to look at while we're talking about the questions. Oh, so this is actually some of my advisors' team taking an ice core, and the next question is about an ice core. So let me do both. So this is a really beautiful ice coring tent. As you can see, it's big. It allows people to stand up, and it's a little bit warmer because you're able to have the snow on the bottom, but then also, you know, the body heat for everybody in there. So how do you tell where to cut an ice core? So I think they're asking, where do you tell how to drill an ice core? So as you can see here, we lower the drill down on this very, very strong wire, and you go down into the glacier and you drill into the ice, and then you remove, just like you would if you were coring in the deep ocean or even in a tree, you know, it's just vertical versus horizontal. You remove the ice. And the ways to tell, you can do a couple different things. You can look at the way that the glacier is flowing. You can do what's called ground penetrating radar, almost doing an X-ray on the glacier. You can look at where other people have drilled it. There's a lot of different things you can find out about the glacier just from watching it and from looking at it. And so there's good ways to tell how to drill that way. And how do you tell the years apart? Well, at the University of Maine, we have a really beautiful laser ablation system, which means that we can shoot a laser at the ice core and get a ton of data about when it's from, the chemistry, all sorts of things. Otherwise, you can look at an ice core visually, and you can sometimes, if the glacier is cold enough, count the layers and actually see where the different layers have formed every year. Obviously, they're not forming as much anymore because we're really losing a lot of glaciers to melt. But over the last couple thousand years, you can see, depending on where the glacier is and how old it is, you can see the layers. We can also use a variety of dating techniques, isotope dating. There's a lot of different ways to tell the years, but the laser technology that we've developed at the University of Maine is a really special method that we're very excited about. Okay, so I also do a little bit of sailing. So this is off of New York Harbor, a tall ship that I was on called the A.J. Meerwald. Really beautiful ship. It's part of the Chesapeake Bay Restoration Project, and they do a lot of teaching. As you can see, it takes a lot of people, some doing a good job, some not doing a good job, to raise the sails. And that's a really, really fun part of doing experience-based field education, because there's a lot of things you can do. You don't have to just go to the mountains or just go see glaciers. There's also sailing opportunities. There's all sorts of different hiking opportunities. I know that when my husband was young, he used to do kayaking in Maine. So there's lots of ways to get involved with earth science, even, you know, if you're doing it in a fun way and learning that way. So some of the stuff I'm currently working on, I was just telling you about the National Geographic Everest project. And that is, just looking at the time, we're gonna have a lot of time for questions. So the National Geographic Everest project was a group of people who all got together across different kinds of science. We've got biologists, geologists, chemists, all sorts of different kinds of glaciologists, and we got together to do this really holistic perspective of science on Mount Everest. So we did all sorts of things at the same time together. And like I said, we're going to be talking about our results in a new journal that's coming out called One Earth. It's going to be a special edition where we get to talk about all of our stuff at the same time. And I don't want to scoop anybody else, but there's some really neat stuff that the biologists found. We were able to, like you mentioned earlier, find plastics and chemicals. The geologists were able to date some of the rocks and find out what the glaciers looked like on Mount Everest. So there were lots and lots of different opportunities to work together across science. And that's a really important part of science, is working together and making sure that you're getting the full perspective and understanding everything that you can about the ecosystem by looking at all the different components and how they work together. And then on the right, I'm part of the AAAS If Then Science Fellows. And so there's 120 of us, and we get together, both together and on our own, with local schools and community groups to spread the word about science and to do outreach, especially to young students, women and men who are learning to be scientists or have the interest in being scientists, and they want to know more about what it entails. So that's a really neat project. Part of what we've done for that is the TV show, CBS Mission Unstoppable. That's on Saturday mornings on CBS. It's with Miranda Cosgrove, and they do an awesome job learning about science. I think there's some on YouTube as well. So that's a really good way to learn about how you can use science and how it can be really fun. There's projects with that too. All right, so that's about all I've got for slides. I'm happy to chat with folks and answer some questions. This is a silly picture of a moose in Maine. It's a lot colder than it looks. Once again, I took my coat off for this picture, but it was actually quite chilly. But I would love to chat about any questions that people have about climate change, about earth science, about traveling, any of those things. You know, I do travel often by myself, and it's not difficult to travel by yourself as a woman, to camp by yourself and to do all of these expeditions by yourself. But I do have a lot of awareness where I am, making sure that I'm safe from bears and safe from other people. So I'm also happy to chat about that and, you know, what it's like to travel around by myself while I'm doing this kind of research. So what the question is, what has been the most surprising finding you found in your research? One of the things that I found that was really surprising was how much the chemicals melting out of glaciers really impact or have the potential to impact downstream communities. I think that even my committee, my team for my PhD didn't expect that it was going to have such a strong impact. And that was something that we are all really concerned about and want to keep talking with local communities about. The next question is the scientific method predictable or done in a predictable manner? Okay, great question. So it is done in a predictable manner. The scientific method itself, like you mentioned, is a methodology. So it's like a recipe, okay? It's the way that you do things. You do step one, then you do step two, right? So first you do an observation, then you come up with a hypothesis, then you're gonna come up with a way to test the hypothesis, then you do test the hypothesis, then you get results, and then you have to spend a lot of time trying to figure out what the results mean. And you might even have to go back and get more data, test your hypothesis again. But that's the way that we do science every time. And that's what keeps all of us honest. That's what keeps the science real. And it also lets other people recreate it so that we are able to do our methodology. And then on the other side of the world, someone that we've never met can do exactly the same thing and ideally come up with similar results. It's a little bit different with field science because all the different field locations are different. But we are really able to duplicate methodology when we follow the scientific method, which is why it's a really, really awesome thing. Do I ever feel nervous traveling alone? I think I felt nervous before. I do have training in self-defense. I have a black belt in karate, but I've also had just, a couple different classes over weekends. When I was a teenager, my parents encouraged me to take some self-defense training. And so I do feel a little bit more confident there, but then I'm also just really aware of my surroundings. I wouldn't want to bring a peanut butter sandwich into a place where I know the bears are and sit there noisily eating my peanut butter sandwich. So it's the same thing for any kind of situation with humans. I want to make sure that I'm making good decisions and being with good humans and not staying away from humans who are not so good. And any tips looking for women looking to travel? Any tips for women looking to travel? Excuse me. Yeah, I think that it's more than possible to travel as a woman by yourself with friends. One of my godmother, she often takes bus trips or tours, and that's a really good way to do it because she's always going to check in with someone at the end of the night. That's something that I would say is that, especially now that we all have cell phones or we have in-reaches for when you're in the field, it's a really good idea to make sure there's someone in the front country who you can always check with and make sure they know where you are. And that's not because of gender. That's true for anybody who's going to be in the field. Make sure they know where you are, how you're doing, and that you're safe, at the same time every single day. Because sometimes, people get stuck in bad situations and they're not able to get help because they don't have anyone to check in with them. Am I seeing an increase of interest in science? Yeah, I think maybe people are getting more interested in science. I think it's becoming really clear to people that science is a really big deal and really important, especially with everything that's happening with the coronavirus. We're really relying on health scientists, epidemiologists, doctors are scientists, to tell us how to be safe and to make us even safer when they develop a vaccine. So I think that science is definitely becoming more of interest. And it's also becoming really clear to everybody that science is everywhere. Science is in everything. Everything is science. So it's really hard to not be interested in science if you're interested in cookies, or if you're interested in hiking, or if you're interested in any kind of weather. All right. Can you explain a little about the polar vortex and what that means? Yes, that's a great question. I know the East Coast, all the way to Chicago, is experiencing low temps and possible snow in May. So I'm going to explain this at a very high level and then shoot back another question if you have more, if you want more details, okay? So we have a pattern of circulation in the world, in the atmosphere, where certain parts of the atmosphere go certain directions. We've got the different wind systems, we've got circulation cells, and they all have acted in a predictable way for many years. Now with climate warming, that's getting a little bit unstable. So some of the winds are going places, they're going higher or lower than they used to go. They're going in different volumes, they're faster, they're slower than they used to be. So what we're seeing with the polar vortex is that this wind pattern over North America has gotten a little wiggly. It's a little wiggly woggly. So where the North Pole used to hold a lot of the cold air and kind of just stay in their little system, now because our wind patterns are shifting, the cold air is able to come down a little bit lower. So even though it seems counterintuitive that something that we call global warming could be causing snow in May and cold temperatures, it's actually because of climate change, because of global warming, that these wind patterns are shifting. And so it causes the colder temps to come down. So I'm going to leave it there, but whoever asked that question, or if anybody has a follow-up question and want more details, go ahead and ask me, okay? All right, how did I decide to become a scientist? So I didn't decide to become a scientist. This is the really funny story. I wanted to be someone who got to explore. I wanted to be someone who solved puzzles and asked questions. And I wanted to be someone who could talk to others about how I see the world and all the intricate parts of it. So not only the really, this is a rock parts, but also what is the rock made of and what is its structure. And I found out kind of late in my career that the best way to do that was to be a scientist. So anyone can be a scientist. All you have to do is be able to ask questions and imagine the answers. And then we bring the scientific method in to answer our questions in a really predictable way, in a methodological way, so that we know that we're coming up with answers that are real, that we didn't actually just make up. So we imagine the answers, but then we test our imaginations. And it's actually really cool and straightforward. And you can be any type of scientist. If you want to be, if you love baking, you can be a baker or you can be a chemist. If you love basketball, you could be a basketball player or you could be a physicist. So there's a lot of different ways to do this. I decided to be an earth scientist because I love exploring and I love the earth and I love hiking. I definitely miss it while we've been, hanging out inside. I'm going to switch to a different photo just so that we have something else to look at for a little bit. Okay. Where do you see climate science moving after coronavirus, COVID-19, and how do we hold on to the gains we've made? I am not sure. I think that there's been a lot of articles speculating where we're going to go with climate change mitigation and response. And I think that it's very unclear. We have an opportunity right now to expand the way that we think about the world and to create a more holistic, sustainable view, to invest in things that are going to be good for the environment and for us in the long term. And I don't know if we're going to do that. As far as holding on to the gains we've made, I don't know that we've made a huge amount of gains. I think it's important to do things like keep all of the federal agencies really strong, but I'm not entirely sure where climate science is going to head next, or where I guess climate change mitigation is going to head next. We will always have climate science because we will always have a climate on Earth. All right, can you tell us about the peer review process? Yes, I was actually just talking to my little brother about this yesterday. Okay, so the way that it works is I come up with a question, okay? I imagine an answer and I test my answer. Let's say my test produces something that I can write about. And so I write about the results and then I share my opinions on it in the discussion. So then I send that in to what's called a peer-reviewed journal. You might have heard of Science or Nature. Those are both big journals. And the editor looks at it and says, hey, this sounds interesting, or this isn't exactly what we're looking for because it's not new or it's not interesting or it doesn't seem like it's done right. If they do want to look at it more, they then send it out to a bunch of not random, but kind of selected people, scientists from all over the world. And those people are volunteering to look at the manuscript. They're scientists from, however they're identified as experts in their field. And they look at the manuscript and they judge the scientific method. How well is the science done? Is it in accordance with the standards that everyone follows? Are the conclusions reasonable? Are the conclusions obviously biased? And then they give all of their opinions about that to the editor and to the authors of the manuscript. It goes back to the editor. The editor decides what they would like to do. If they want to allow the authors to rewrite their manuscript or make any edits, or if they want to say, okay, there's too many problems with this based on the reviewers. I right now am editing a special edition for a journal, and I get all the reviews back on the manuscript and I take them very, very, very seriously. Those are the people who are experts in the field. And if they say, hey, don't publish this, I usually get 3. And if more than one person says, hey, don't publish this, and they've got good reasons, I take it very seriously. So that's how we try to prevent bias, is by having this blind peer review. Let's see. What do I like about being a professor? I love mentoring people. I love learning from the students that I work with. I love how incredibly inspiring and interesting they are. I just started working with a new student at CU Boulder who's been really inspiring me recently. And I love everything about my job. So being a professor gets to, gives me the opportunity to do this stuff. I hear a lot of people use global warming and climate change intermittently. Is there a difference? Not really. Global warming was something that, we called it earlier when we didn't really understand some of the nuances of how adding more CO2 and nitrogen to the nitrous oxide to the atmosphere would change things. But there's so many different dynamics going on that climate change is a little bit easier. And it also, back to the question about why it's snowing in May, it also kind of describes what's going on with things that are weird, but they're not weird in a hot way. So it's going to snow, which is weird, but it's not hot. Do I have a favorite scientist? Yay. Let me think about that a little bit. I'm sure I do. Carl Sagan. Carl Sagan was an astrophysicist and awesome science communicator who did the first Cosmos series, and he wrote my absolute favorite book, which became a movie called Contact, and it's about a scientist traveling into the universe to encounter extraterrestrial life, and it's awesome. I think it's on Amazon Prime if you guys want to rent it, and it's totally friendly for all ages. What is the best way to show that science is not just for scientists? I think just kind of what we've been discussing about knowing that and really reiterating that everything you do every day is science. Science is just a way of understanding the world and perceiving the world. So, I've got a candle on my desk and some incense, and the incense burns because of chemistry. And the physics explains why the candle burns. And I think that it's, a great opportunity to ask ourselves as frequently as we can, hey, I'm doing something today. What kind of science is this? I'm baking. This is chemistry. I am hiking. This is, the way we perceive the world around us is part of earth science. And it's fun to keep asking those questions. So, if I had some kiddos at home, I would probably do something like that. All right, what is the big research question I have at this moment? Well, we just wrapped up some of the big research questions around Mount Everest. So I was really curious about what impact humans were having on Mount Everest as far as pollution goes. And like I've mentioned, we did find that humans are having a really big impact, not only in the macro, we've all seen pictures of trash on Mount Everest, but also in the micro. And so we're going to be releasing some work about that pretty soon that I'll be able to share with my networks. A good way to talk to me off of this forum is on Instagram. I'm Dr. Kimberly Rain. I'm also on LinkedIn, and I will be putting any kind of updates to our research on both of those. So if you're interested in what we found on Mount Everest, that should be coming out in the summer. If a teacher wants to access your research and is behind a paywall, can they contact you? Yeah, of course. And also there's a online community called ResearchGate, like gate to, I don't know, a house and ResearchGate. And that's where a lot of people either put some of their manuscripts that they can share, or you can ask them for the manuscript and they can send it to you. So that's another really good place to contact any kind of scientist. A lot of people are on it. A lot of people are on it. What are my favorite places I've visited? Well, I love Alaska, but I did not love being trapped on a glacier. So that's not something I would like to do again, but I do love going to Alaska. I adored Switzerland. I had the opportunity to go to Switzerland to work with some people at a great university called ETH Zurich. And I did a 1 week seminar there that they had a bunch of students come. And that was incredible. I highly recommend Switzerland. But Banff National Park in Canada was also just stunningly beautiful. A lot of the mountainous regions on our planet are incredible, and I really highly recommend them. Oh, obviously Antarctica was very special. The boat you know, the National Science Foundation provides all of the boat and gear, and it's not very fancy, and it's, you know, a little bit stinky. It's a diesel boat, but it's really, really good experience. Do UV rays or IR rays influence the warming of the atmosphere? Yes, great question. Both. So there's different kinds of UV rays, remember A, B, and C, and infrared radiation too. There's a bunch of stuff coming off of the sun, basically, and they are all, strengths isn't the right word, but let's use that word for right now. They're all different strengths, they're different wavelengths, but I've always found that a little confusing. So they're different strengths and they're different qualities, okay? So they've got big wavelength bands or small wavelength bands. They're different. It almost feels like densities, like when you look at it, it's got all these different qualities to it. And so all of the things that are coming off of the sun like that go through our atmosphere do influence the warming. So we've got this beautiful protective layer on the outside of our planet, almost like a semi-permeable envelope. So you can kind of move through it, but it does protect all the air and keeps everything in. And so when the UV rays and when the infrared rays come through it, then it reflects off of what's in the atmosphere a little bit, and it's absorbed by what's in the atmosphere a little bit once it bounces off the earth. Again, ask me more questions if you want more specifics than that, okay? Because I'm trying to keep things kind of high level. What are good and accessible resources for ongoing climate change information? Ooh, good question. Okay, so I guess it depends on what kind of climate change information you're looking for. If you're looking for news, I know that The Guardian, the US version, has a really good climate office, as does the New York Times. I know the writer for the New York Times, he does an excellent job. If you're looking for research, there's a bunch of fun websites and resources like on Facebook that do post research. I think there's like science news, weekly science updates. There's also, you could reach out to any university that does it. So for example, the Climate Change Institute where I work, we post any research that's up and coming that we have put out. And then, you know, like I mentioned earlier, you can always go on ResearchGate and look at what's coming out in the climate science world. Science Magazine also is a really good resource. They have news articles as well as journal articles. So that's kind of like a go-to one-stop shop for everything. Oh, does my doggo get to travel with me? Let's go back to the doggo. My doggo is so good. My doggo had to go downstairs so that she didn't bark because she's a cattle dog. So she really likes to bark at things to let them know that this is her territory. She is really, really good. She's a rescue. We got her when she was about 4, and we have just loved her so much that we've fixed her and made her feel safe and happy and calm. Because when we got her, she was not feeling safe at all. She doesn't often get to travel with me because of airplanes. She's not the kind of dog that would like to go on an airplane. Obviously, she went to Maine. She now is in DC with us. Anytime we go hiking, or even if we go paddling, sometimes when we go on a kayak or a canoe, more like a canoe, she'll go with me. She loves to go in a canoe. And she's pretty good at sitting down and not jumping around. Sometimes she'll see a fish and she'll want to jump onto the side of the boat to look at the fish. You have to be really careful that she doesn't tip the canoe over, because if it's not too warm in Maine, sometimes that's a little hard to deal with, getting all wet. Am I planning any future research already that you can tell us about? Oh, I don't think that I can tell you about, unfortunately. I've got some stuff in the works with the Arctic, and yeah, I don't think I can tell anybody about it just yet, but you know, I've got, like I said, that website and Instagram and LinkedIn, and I'll be putting updates on there. And I would love to do another talk with NBTI with you guys. So hopefully I'll get a chance to do that again, maybe in the fall, maybe in the winter, even next spring. And then I can let you know everything that's changed and all the new research that's coming out. Have I noticed any phenological changes in my travel that have made me stop and take notice? I don't really know what that means. I guess can you, whoever asked that question, can you just go ahead and send me the question again, but with a little bit more specific detail? I think you're talking about the way that animals and plants live and when they're awake and when they're asleep, and their habits. But can you just ask me the question again in a different way? That would be awesome. I've been thinking a lot about saying I don't know and what it's like to say I don't know as a scientist recently. And I think it's really important to acknowledge that we don't know everything. And that question's a great example of that. So ask me again, please. Have I ever presented or attended a big international conference? Yes. I go to the American Geophysical Union conference for the last few years. It was moving. So it was in New Orleans, then it was in DC, which was close to me. And then it was in San Francisco, back where it normally is last year. And that is an awesome conference. I was actually just looking, I've got a bunch of temporary tattoos. I wish I had a camera so I could show you, but there's science temporary tattoos that the American Geophysical Union was giving out at their last conference. And that's really fun. As far as conferences that I recommend that you attend, the American Geophysical Union conference is awesome, but it is a lot of specialists in the field. So you kind of have to know some of the science language that they're using. So, if you are an educator or if you're a scientist, it's great. But if you're a student, especially if you're a student before high school age, it probably would be better to wait and to go to that when you're a little bit older. And let's see, sorry, we just had a little bit of a bump. Okay, and then there's a lot of other different types of conferences depending on what you're interested in. So there's conferences for biologists, there's conferences for geologists, and a lot of them do cater to scientists. So it kind of depends on what you are looking for. I know that there's a number of new outreach opportunities that are happening for students and educators alike, but I don't know that they're in conference format. So I think probably the best way to go about it would be to just Google in your region, kind of what you're looking for. So are you looking for biology? Are you looking for oceanography? Are you looking for sociology? And your region and where you live. Ask me another question about that if you have another question as far as like specifically what you're looking for. Maybe we can brainstorm together. Okay, so the person who asked me the last question said, for phenological change, I mean, maybe the time of year birds migrate out of season, plants blooming when they shouldn't be, or animals and birds where they don't belong. So I have heard a lot of discussion about that. That's not exactly what I focus on, so I don't have specific details. Definitely have seen with my own eyes, right? Observation is the first part of the scientific method. I have seen changes as far as when things are blooming and when birds are migrating. And I know that it's been a big point of discussion among the scientific community. Little side note, one thing that's been kind of interesting that people have been talking about is, while everyone's in their homes with coronavirus prevention, that the birds have become a little bit louder. So they have a little bit more space to talk and sing to each other. And so they've been a little bit louder, taking up more space. So I don't know if you guys have noticed in the morning where you live, but in the morning where we live, it is noisy with all the birds talking to each other. I think Science Magazine put something together about that. So if you're interested in that topic, that would be a good place to look for it. What science skills should we be helping young people master in the classrooms? So I think this is a little bit hard for me because I really didn't like science classes when I was younger. I really dreaded all the way up through high school science classes. And I think the trick for me was that I didn't understand that science wasn't just about, what we do in a lab or what we learn in a textbook, but it's also about real world experiences. honestly, whether it's, dissecting or creating the inside of a frog, or whether it's about walking around and observing the world around you. I got really into science once I learned that you could go out into the field and name different birds and name different trees and know how they interact, and that was science too. So I think that, while it's important to, this question was, what science skills should we be helping young people master? So I think while it's really important to get, some of the basics of how, chemical equations work and how bonds are, created and broken and how physics works, it's also really important to do the really fun, additional component of how do we use it in our lives and what does that mean for us? And, maybe that's learning about bonds, and then it's cooking. I had a teacher once teach us about cells by letting us make pudding with a bunch of different kinds of candy in it to represent all the different organisms or all the different organelles within the cells, the mitochondria and the ribosomes and everything. And I still remember that exactly because I got to eat chocolate pudding and I got to put different kinds of candy in it. So that kind of fun experience, I think, is really important. In addition to any kind of skills that we're teaching, it's also important to show that science isn't something that lives separately. It's not something different. It's part of everything we do. Okay, thanks for the awesome questions, guys. Can you talk more about the pollutants you have found in the ice in the Arctic? Sure. You said I focus more on chemicals and pesticides. What have I found? So in the Arctic, I looked mostly in Alaska, so we'll talk about that. And I found the legacy pesticide, so the old and banned pesticide DDT. So that's the pesticide that Rachel Carson wrote about in Silent Spring. I'm sure most of you are familiar with that. And it's really, really bad for animals. It's really bad for bird shells. Turns out it's really bad for humans too. So I found DDT, and I found a compound called hexachlorohexane, which is also called lindane. It's another type of pesticide, also really not great to eat for humans or organisms in the ecosystem. Like I said, we also found PFAS, which is like Teflon on Mount Everest. I also found DDT there and lindane again. You can really find DDT and lindane in almost any glacier that you look. It's just the different levels based on how close you are to settlements. And then the other part of the question was, what is the most shocking thing I found? I don't want to scoop myself here. I guess the most shocking thing that I found was the amount of very small things that we found on Mount Everest. So the amount of micro plastics and the amount of chemicals that you can't see with your eye, but it's all around us. And also just the realization that chemicals are what we call ubiquitous. Human chemicals are everywhere, and it doesn't really matter where you go in the world. You can go to a glacier in the middle of Alaska and be in an 8-day snowstorm, and you're still going to find pesticides that have been banned for 40 years. So that's a real bummer. And I'm not really sure what we do about it yet, but I do think a lot about what we're going to do about this. Probably stop using some of these chemicals, but I don't know how we take them out of the environment. What is the scariest and most disturbing thing I've seen that's caused by climate change? Whoa, okay. Oh my goodness, the scariest thing. Oh man. Well, I think hurricanes are really, really scary. What happened with Puerto Rico was horrible. Yeah, let's go with hurricanes. The fact that the hurricanes have gotten really, really strong, and we're expecting this year potentially to be the worst hurricane year ever because of the warmth of the ocean and how that is really impacting the ability of hurricanes to form. So I think that's really upsetting. I did talk last year with the New York Times and with some people for a journal article about chemicals that are released during natural disasters. You know, anything that we put in our house, if our house is unfortunately burnt down or if it's flooded, those chemicals go everywhere. So that's a very scary thing that I think we really need to talk more about. Someone said, I've always wondered how you can determine the temperature from the ice core. Like the temperature of the ice core? Okay, so again, send me another question to clarify this, but you determine the temperature of the ice core with any kind of thermometer system, you know, just like you would for a person's temperature. You can use one of those thermometers that we're all seeing now that people can stand away and use almost like what looks like a little laser gun. So there's a bunch of different ways to determine temperature of ice core. And then how far back in time can we go with ice cores? Well, you can go back as far as the glacier is old. So I don't know what the oldest, I think Vostok Lake, which is a lake in the middle of Antarctica, I think probably that's the oldest sample we've ever got. But yeah, I think that's probably the oldest sample we've ever gotten. I don't know the date on that, but I know it's, I mean, we're talking thousands of years here. I'm trying to figure out, you know, how many thousands of years, but lots of them, millions of years. And I can, if that person wants to contact me, I can give you a real answer offline. How do you use ice cores to determine temperatures? Oh, great. Okay. So you can use a number of different measurements from ice cores. So remember the ice core is kind of trapping whatever's in the atmosphere at the time. And that does include isotope signatures. So you can use isotopes, which I'm trying to think of how to describe this. It's kind of an understanding of the way that water is moving in the atmosphere. And you can use that to understand temperatures. It's not a direct proxy. Like I wouldn't be able to tell you, oh, it was 50 degrees on this day in this part of this, you know, the century. Tree rings are really good for that, or maybe a little better for that, but you're able to get kind of climactic trends. Okay, so you also have to think about the snow gets squished down really, really little to become a layer of ice. Oh, my dog just came in, so you guys might hear some barking. To become a layer of ice. And so you're not going to have potentially a day-to-day measurement, but you could even have a year-to-year measurement of what's going on in the climate overall. So I think we've got about 5 more minutes. Oh, looks like that's all the questions. You guys are perfectly timed. Excellent job. If you have any other questions, I'm happy to stick around for a couple more minutes. I'm really grateful that we had the opportunity to do this. So thank you all so much for joining. Please feel free to follow up with me, like I said, on Instagram. You can email me on the University of Maine website. They have my email address, my professor email address. So let me know, you know, if I can do anything else to do outreach during this time, or if you have any questions that I wasn't able to fully answer. And yeah, thank you all so much. This was really fun.
Thank you so much. That was wonderful. My favorite takeaway was your comment about we don't know everything. I love that you said that. And we're going to take you up on the, we got all excited when to take you on the updates, to get the updates on your research. So we were texting back and forth about how excited we are that you were willing to come back and share that with us. So thank you.
Wonderful.
Thank you very, very much. Enjoy the rest of your day. And we appreciate you.
Thank you. Thanks for having me. Really appreciate it.
Bye.